Hello everyone, welcome back to Lambda Alpha Education. In this short series, I'm going to be going through a bunch of things related to proofs. So proof tends to be arguably one of the harder topics in Leaving Cert Maths, and I want to help you get through it. So we're not going to be doing any of the geometric proofs, so no constructions or theorems 11 through 13, which I have done videos on. I have done theorem 11, 12, and 13 videos. So you can look at them if that's the proofs you're looking for. But the proofs we're going to be talking about, we're going to be talking about proof notation and then the major proofs that can come up in terms of algebra proof. So you have direct proof, contradiction, induction, which covers divisibility, inequalities, and finally, unfortunately not drugs, DMT is not dimethyltryptamine, it is actually de Moivre's theorem. So, check out the recording, yep. So the first thing we're going to do in this video, so each of these is probably going to be their own video, is we're going to be talking about some proof notation that you might use in your answers. So a lot of these are very formalized symbols, and I believe they're all given in the log tables anyway, but it's fairly good to understand this sort of proof notation. So the first one, the most common one, actually I'll just title this proof notation. The one that probably a lot of people are most common with is these three dots. These three dots stand for therefore. So usually when you're doing steps or simplification, so if you were to do, say, like a simple expansion, so say like this, for example, you would say, if you were to solve this, then you do therefore p squared plus 2p plus 1 is 4, therefore p squared plus 2p minus 3 is 0, and then go from there. So a therefore is used in pretty much every stage of proof. Now the next two can be quite useful for induction proofs, although it's not formalized. It can definitely impress the examiner, and these are an upside down A and an upside down E. The upside down A represents the words for all. So for instance, if it was written like this, this would mean, if I just said, for all positive integers. This elemental sign is just kind of a link. So just for all, usually it could be like for all x. So for all numbers in the natural numbers, it is followed by this, which means there exists. So for example, using all of these together, if I were to write for all natural numbers, there exists a square of that number, I would write for all any number that's an element of the positive integers, there exists some number p. So there exists a p such that st is such that there is a special symbol for this, but we'll get onto that later. So for all numbers x that are in the positive integers, there exists a number p also in the integers. So there exists number p also in the integers such that p is x squared. Which is in itself true. It just means that all numbers within the naturals have a square. So if you square x, you get p. So just to rewrite it again, for all x in the natural numbers, there exists some number p also in the naturals such that p is that number squared. So those are the fairly common ones. There is actually one more that I tend to use when writing answers, and it's this one here. It's an equal sign with an arrow after, and this means implies. So people who might have done actually computer science and bits of logic might understand this. So for instance, this would be like A implies B. So whatever A is, B is as well. You'll see it a lot in especially old Greek logic, but I tend to just use implies for when I'm writing down my steps. The next one I've seen a lot of people mess up, and it's the triple stacked equals, and this kind of has a couple of meanings. It means equivalent to when we're doing identities. So an identity is not an equation, you're just trying to balance each side. So it could be like x plus 1 squared is equivalent to saying x squared plus 2x plus 1. They're not equal per se, because we're not solving the equation. We're just saying that these two are linked by this triple stack equals. In geometric proofs, this is also congruent to. So if two triangles are congruent, they would be linked by this. So for instance, triangle ABC congruent to BDC, for example. There are two more. There are three more actually. The one for such that is a colon, so that means such that. Again, one that computer scientists might know is the V, which just means negation. So if you're looking at De Morgan's laws, for example, I can't remember off the top of my head, but negation is just, say, like, not A. So that is just not A. Now the final one is QED. This is a very common one you'll see. QED is a Latin phrase and it stands for quod erat demonstrandum. And what this means is it just shows that the proof has been complete. So this is at the end of proofs when a result has been shown to be true or to fit the initial prompt. Quod erat demonstrandum just means it has been shown, as in, there you go, the proof's over. Another common one you might see to signify the end of a proof is a box with a fill-in, but I don't tend to use that. I tend to just use QED because that's what a lot of the books use. So hopefully that covers all the required notation for proofs.